Okay, so now we're going to be looking at stuff with the definite integral as area, and the way that it's often phrased, and this we're on number 27 here, by the way, in the workbook, is the area under the curve of f of x between x equals a and x equals b, and we're going to look at these kind of like as a lower limit and an upper limit, kind of from a to b. This is how it's written here. So that part that we just underlined, we use this integral sign with two limits of integration. And we've used the integral sign before with antiderivatives. But now we're kind of adding more to it with numbers and more specific calculations. Okay, so the area of one rectangle, we kind of figured out, is f of x times d of x. It's that height times the base, or the length times the width, however you want to say it. But what happens is, let's say instead of that box, instead of one long box, like this one, kind of thing, let's say we took that box, let's make the inside of this orange. There we go. Let's say we took this box, but we shrunk it down. And we said, we're going to shrink that inside, that width down to nothing. And then we take this and we make a whole bunch of these. So I'm going to duplicate, duplicate, duplicate. Oops. Duplicate, duplicate, duplicate. So now we got a bunch of skinny boxes. And what we're going to do with those skinny boxes is fit them inside the curve. And then we're going to add up all those little skinny boxes. And when you add up all these, then you get something that's so curvy and smooth that it really fills in the area perfectly. There's no estimation. It actually gets it broken down to infinitely small rectangles. Sometimes they call that like an infinitesimal width, really small width, and then we get this exact area. So we're looking at exact areas. That's the big difference. Okay, so a couple of things going on here. Let's talk about area in general. Area of a box, we could say is like a length times a width. Now we know that moving to the right is positive in the x direction, and moving to the left is negative. And when we're moving up, that's positive, and when we're moving down below the x-axis, I should say, down here, that's going to be negative. Okay, so if a is less than b, then that means I'm going from low to high. So I'm moving to the right. That's a positive movement. Then our dx is going to be positive because let's say I moved from 2 to 5. This distance in that direction is going to be plus 3. But it's kind of weird when you go the other direction if b is less than a. So let's say that I moved from 5 to 2. Well, if I want to move from 5 to 2, that's like a minus 3. And if it's in reality, it's like I'm going from 5 to 2 this way. So it's like a minus 3. So that's really what we're looking at, is whether it's positive or negative based on the movement. Here's kind of a summary of that idea. So if the curve is above the axis, meaning that we're up, we're positive, and a is less than b, so we're moving to the right from a to b, then we're going to have positive, because this is positive times positive. But let's say the curve is below the axis, we're moving down, that's not positive, in fact that's negative. Let's take that off. Okay, that's negative. And if we're moving left here, this is also negative. So it's pretty easy to figure this out. Positive times a positive is a positive. Positive times a negative is a negative. And so on. Now let's look at this, a couple of basic things. These don't make a whole lot of sense until you see it and how it's working. But the general idea is that if you don't move at all, so we're going from A to, wait, no, we stop at A. So how much did we move left and right? Our dx would equal 0. In other words, our width of one of those little lines actually equals 0. It's not approaching 0. It's not infinitesimally small. It is 0. And when you multiply an area with one of the dimensions 0, you're going to get 0. So if these two numbers are the same, top and bottom, that's going to be 0 for the area. Now conversely, with going one direction, if you go the opposite direction, so we're going from A to B, but then B to A, if you flip, so let's say I want to go from 2 to 5. Well, that's going to give me negative or positive 3 change. But if I went the other direction, that's going to be the opposite of that, the inverse. And that's where this negative comes from. So if we switch these two letters, then this becomes negative. Okay, now this last one, this is actually a pretty big deal. Let's say I got the area, but I split it here in the middle. And I take another area. And we're going from A to B, but we got a C in the middle. I can add this area, which would be the integral from A to C. And then I could add this area, which would be the integral from C to B. And if I add those two together, then I get the whole thing from A to B, from the start to the finish, and I can cut out the middle. This is actually more important because we're looking, oh, I didn't do it the way they had it. Let me set it up here. They switched the C and B. I usually put the C in the middle. But that changes all of this stuff here. The A is still on the left side, but the C and B are switched. So it's from A to B, and then B to C, and then A to C. So that means B is here in the middle, C is on the other side. So we can add areas, break them up, and combine them. It's kind of like combining like terms or breaking them apart. Very helpful. Okay. So we're not even looking at complex versions of calculus right now. We're just looking at area. So if I'm looking at, oh, look at this, the area from 4 to 4, you guys should know something about that. We didn't move left or right. So what's the area from 4 to 4 between the line and the curve? It's 0. Automatically 0. For this next one, we're going to have to color code a lot of this stuff. Let's start with blue. So 2 is blue. From 0 to 1. So I'm starting at 0, then I'm going to 1, so that's already a positive. And now here, this area above is also positive, and it's just a box. Look at this. It's a perfectly simple geometric shape. Now let's assume that each of these is 1 unit, so I'm 1 by 2 tall, and so then my area is 2. It's that easy. So easy. So I'm going to erase what I have there. Pause the video if you need to take a look at it. But I'm going to redraw in here but with a different color. So that's gone. Let's look at red now. So we'll do 3 in red. And for 3, we're going from 1 to 3. So from 1 to 3. We need to find this area. Well, notice from 1 to 3, that's a positive, and we are above the x-axis, so that's positive, positive. And this is a triangle. What's the area of a triangle? Let's think about this. The area of a box is just the base times the height, or length times width. The area of a triangle, I hope you know this, is 1/2 the base times the height. Well, the base in this case is 2. And the height is also 2. So altogether, that's going to equal 2. All right, now here's where it gets kind of interesting. Because I'm going to redraw this blue area in here. I got this box here that's also worth 2. I know the area from 0 to 1. And I know the area from 1 to 3. And if we think back for a second, if we know from 0 to 1 and then 1 to 3, we can add these two pieces together. We can say A plus B equals the total. So this is really the integral from 0 to 1 of f of t dt plus the integral from 1 to 3 of f of t dt. And we know each of those. The integral from 0 to 1, as per number 2, is 2. And the integral from from 1 to 3 is also 2. So what's the total area? It's 4. That was piece of cake. All right, let's look at number 5. For number 5 here, we're going from 3 to 6. So I'm going to do this in purple. This is right here at 3. We go 4, 5, 6. So this is a triangle. We got a base here, and it's moving in the right direction, so that's positive. But now the curve down here, this is below the x-axis, so that's going to be negative. And our base is, this is equal to 1/2 base times height. It's a triangle. So it's going to be 1/2, and the base is 3. The height is 1. But this also has to be negative because we're moving positive in the right direction, but negative in the lower direction, below the x-axis. So this is going to equal -3/2. All right. What's happening in number 6? Take a look at this. It's the same as number 5, but it's flipped. 3 and 6 are flipped. And what does that do to your answer? Well, if you think back for a second at the pieces we reviewed here, when you flip on, what's it called? Property 2, I guess you want to call it here. When you flip those limits and you work backwards, you actually get the negative calculation. So the answer to number 6 would be this answer, but negative. So negative, negative, double negative makes it positive 3/2. Okay, so that's 1 through 6. I think we have some more with this same picture. Let's take a look. Yep, same picture, but now just more stuff. Okay, let's look at from 6 to 0. Okay, now this is going to be kind of interesting because for 7, I know the integral from 0 to 1, or I should say from 0 to 3 of f of t dt is equal to, from the previous page, that was 4. And the integral from 3 to 6 dt is equal to -3/2. Now notice that if I'm going from 0 to 3, then 3 to 6, and I put these two together, that's going to give me a total from 0 to 6. So this is really equal to these two numbers added together, 4 plus -3/2. So I'm going to rewrite that as 4 plus -3/2, which in this case is, how much is that? 5/2. All right, number 8. Now we're getting into circles. That's kind of interesting. So let's look at circles. We got these circles happening. It's actually a semicircle. Let's do it in green. So I'm looking for this area for number 8. From 6 to 10. 6, 7, 8, 9, 10. So I see that it's a circle. I know that the area of a circle is equal to pi times the radius squared. Well, in this case, my radius is 2. But it's only half a circle. So the area of a semicircle is equal to half pi r squared. So this is going to be 1/2 pi r squared. We just got to figure out what that radius is. Well, the radius from 8 to 10, or from 0 to 2 here, or here, it's the same on all three sides, is 2. So let's simplify this a little bit. That's 1/2 of 4, or 2 pi. Now again, when you flip that bottom and top, it changes your answer from a positive to a negative, or from a negative to a positive. So for number 9, the answer is just going to be -2 pi, because the top and bottom were switched. Okay, number 10. Number 10. All right. We're combining so much in this one. If I know the integral from 0 to 6, and I know the integral from 6 to 10, if I add those two things together, that's going to give me this here. And we're, of course, looking at f of t dt, f of t dt. Excellent. So what are those two values? The integral from 0 to 6 we figured out was 5/2. And the integral from 6 to 10 is 2 pi. And I can't really do much to make that look simpler. I could combine those two terms and make it one fraction, but For the most part, that's as simple as it goes right there. Now this is where it gets a little bit different. If I'm going to look at this as an inverse number, or the inverse of that number, because I'm switching 10 and 0, I really just have to multiply my answer by -1. So in this case, it's going to be -1 times 5 halves plus 2 pi, or -5 halves minus 2 pi. Either one of those ways would have worked. All right, let's look at this last one, and we will do it in, let's pick a new color. Have we done purple? We have done purple. Let's pick a brand new color. How about orange? So number 12 is going to be an orange. We're looking at the integral from -1 to 0. From -1 to 0. From -1 to 0, there's -1, and here's 0, and we're trying to find this area. Now there's a couple of ways that I can do this. Sorry about that, got interrupted by the bell, but let's keep our momentum going here. We're trying to find the area of this shape. Now you can look at this shape in two different ways. You could call it a trapezoid, because it is like a trapezoid. It's got two parallel lines here. Or you can split it up into a triangle and a box. I don't care how you do it. I'm going to do it as a triangle and a box just because that seems easier, even though it's the same thing. So this box here is 1 wide by 2 tall, so the area of that is 2. The area of this triangle is 1 wide by 2 tall, but you got to split that in half. So 1 times 2 divided by 2 is really 1. So what is the area from -1 to 0? It is 2 plus 1, because that's the box, plus the triangle, which is just 3. Okay, let's see what else we got with this one. Okay, so now we got the same idea, same picture, but we're just doing more calculations of it. So let's see what we have. From 0 to -3. Okay, so if we're going from 0 to -3, that means we're here and then we finish there. So we're moving to the left. Notice that that's a negative number there. And from 0 to -3, we got all this area. Now there's a couple of things that we can do, and I'm going to show you how we can kind of split this up into geometrical shapes. So now I got 3 shapes here. I got this box, which is 2 by 2. So the area of that's going to be 4. And I have this triangle, which is 2 wide by 1, 2, 3, 4 tall. So the area of that is going to be half of 2 times 4, or half of 8, which is 4. Then this last triangle is 1 wide by, how tall is it? 1, 2, 3, 4, 5, 6 by 6 tall. So we're going to take half of that since it's a triangle. And that'll be 3. So the 3 areas that I have here are 4, 4, and 3. But notice that we are above the x-axis, but moving left. So that kind of gives us a negative times a positive for our product there to find that area. So then the area is going to be negative, and then we add these 3 numbers together. 3 plus 4 plus 4, which is really -11. Oh, wait a second. I just did that backwards, because we start here at -3 and we move to 0. So we are moving forwards. When you're moving forwards, it's a positive direction. So that negative doesn't need to be there at all. So let's take it off. Gone, gone. So the answer is 11. But that kind of helps us see what's happening here. So when we're moving from 0 to -3, so it's going left, and it's above, which means it's a negative times a positive. So that's going to be a negative. So it's the same as what we got before, but we just multiply it by -1, and we get -11. All right, now let's talk about -3 to -4. This is a little bit different here. We'll do this in brown. Excuse me. Negative 3 to negative 4 means we're going to go left, which is negative, but we're also going down, which is negative. So we're going left, and then the area is also moving down below the x-axis. So that's a negative times a negative is going to equal a positive. So this area is going to be positive. I just got to figure out positive what. Well, it's a triangle. I know that I have a length of 1 for one dimension and 1 for the other. So in other words, this base equals 1 and height equals 1. You multiply 1 times 1 and you get 1. Cool. Excellent. Easy. Now from 0 to negative 4, well, remember, or from negative 4 to 0, pardon me, from negative 4 to 0. That's like taking your answer from negative 4 to 3, and then, or negative 3, and then adding to it the answer that we got from negative 3 to 0. Because now we have negative 4 to negative 3 to 0, and we're going to add them together and get a total. Okay, so from negative 4 to 0, or from negative 4 to negative 3, that was 1. Ooh, we did that wrong again. My goodness, Mr. Butler. If we're moving from negative 4 to negative 3, that is a negative. Because we're going this way, which is positive, and a positive times a negative is not positive, it's negative. So we're moving right and then down. Okay, so this is going to be a negative 1. That's our first area. Plus the other area from negative 3 to 0 is 11. So we add those two together and we get 10. What about from negative 4 all the way to 10? Oh man, this is going to take a lot of work here, because now we're looking at the work from negative 4 to 0, which we just figured out, plus the integral from 0 to 10. So let's check that. What do we got? If we move back, I think we have from 0 to 10. Yes, we do. And we saw that it was 5/2 plus 2 pi. So this one down here, this is 5/2 plus 2 pi. And the integral from negative 4 to 0, we just figured out, is also 10. So all we have to do is just add those two together. So we got 10 plus 5/2 plus 2 pi. We could combine these two rational numbers. 10 over 1 is the same as 20 over 2. So that's going to be 25/2 plus 2 pi. Okay. Now let's see what we got. Well, we know that the answer for the area from 0 to 10 here is actually 5/2 plus 2 pi. And this says take the absolute value of it. So if we were to take the absolute value of that, well, that's still 5/2 plus 2 pi. No difference. But now this next one's a little bit different. Notice this, absolute value. What does that change? Well, what that changes is any of your areas that were negative, for example, this one here, are now positive. So let's talk about these areas. We had, this was 2 plus another 2, so this area in here, this is 4. And we figured out this area was pi r squared divided by 2, so this is 2 pi. And then this bottom one here, this is negative 3/2. Let's get our pencil out here. Negative 3/2, or negative 1.5. And if we combine all these orange ones together into one area, that was 4, 4, and 3, then that's going to be 11. Whoops, let's make that blue. And then this little area down here, this little tiny area, is negative 1/2. Okay, so now let's go back to what we were saying here. This says absolute value. What that means is all areas are positive. So these negative 3 halves and this negative 1 half are not negative 3 halves and 1 half, negative 1 half. It's really 3 halves. So the integral from 0 to 10, let's break this up, is going to be the integral from 0 to 3 plus the integral from 3 to 6 plus the integral from 6 to 10. And again, it's f of t dt for each of these. But the first one, from 0 to 3, we said that was 4. And then the next one was negative 3 halves, but now it's the absolute value of that, so that's just 3 halves. And the last one is 2 pi. So if we add this up together, it winds up being 11 halves. That's what 4 plus 3 halves is. It's 8 halves plus 3 halves plus 2 pi. Oh, all right. So now let's look at this last one. It's this, or last two here. From negative 4 to 10. From negative 4 to 10, that's going to be the whole, every area added together, but we just do the absolute value of that number. Well, this is interesting again. Because the absolute value here is on the outside, we actually find the area, then take the absolute value. So that's like taking the absolute value of what we got in number 17. So what's the absolute value of 25 over 2 plus 2 pi? Well, it's still 25 over 2 plus 2 pi. Now, if that were a negative number, then we would have to make it positive. But it's not. Okay. Now, this last one, though, this is a little bit different. Two things are happening. It says all areas positive because we're taking those values that were negative, but we're making them positive before we add them up. Because this integral really means add it up. And then we're also going to multiply them by 2. We're going to double them. So that means we're going to have 1 half plus, what's the other negative one? 3 halves plus, then the orange ones that we had were 11 plus 4 plus 2 pi. Then we're going to multiply all that by 2. So what's 1 half plus 3 halves? That's 2 plus 15 plus 2 pi. We're going to multiply that by 2. So now we got 2 times 17 plus 2 pi, or let's see, what do we got? 30 plus 4 plus 4 pi. So 34 plus 4 pi is what we would get, simplifying all those numbers. That's a lot of work. I think we're going to stop the video here. Let's take a peek at the next slide, but we're probably going to stop there just for a quick break. We'll split this up into 2 halves. Yep. You know what? No, actually, I will finish this. I'll finish this. Because the general idea now is we're just splitting these problems up. Oh, those other problems are from the homework. So, never mind. We are going to finish this. So we got some things here. We got from negative 2 to 5 is 18 for F. And from negative 2 to 5 of G is 5. And from negative 2 to 5 of H is 11. And from negative 2 to 8 of F is 0. Okay, so let's see what we can do to do each of these pieces. Now remember that we can split up an integral into multiple terms the same way that we could a derivative. So this I could rewrite as the integral from negative 2 to 5 of F plus the integral of negative 2 to 5. That's really small writing there. Let's clear this page. Let's make this a little bit bigger, a little bit easier to read. There we go. Alright, so for this first one, number 22, we're looking at the integral from negative 2 to 5 of F plus the integral from negative 2 to 5 of G. We can split it up and then just add them up. So that's going to be 18 plus 5. Simplified would be 23. Now for this next one, it's doing something very similar but slightly different. Notice this little negative sign here. That negative sign just means subtract whatever that value would have been. So we got 18 plus 5 minus negative 11. Well, that means I'm going to add those two right there, and that's going to be 18 plus 16, which equals, in this case, 34? Yeah, 34. Okay. Two things are happening. Hopefully you noticed them. First of all, we switched these numbers. So I'm going to switch them back and say that that's going to be negative times whatever my answer from negative 2 to 5 of 4 times the g of x dx. Well, we know that the value for g of x dx from negative 2 to 5 is 5. But we're going to multiply that by 4 and then by a negative. And altogether that equals negative 20. Okay, for this next one, a little bit different. We haven't quite gotten there, but g of x plus 2. Well, so what did that do? So what we're doing is we're taking our function, and if we're doing plus 2, that means that we're up 2 higher. So we have this box underneath it. Let's say here's our g of x, but now we've added this area, this box underneath it. And that box, it goes all the way from negative 2 to 5, so it's 7 on the base here, and it's 2 tall. So the area of this 2 from negative 2 to 5 is going to be 14. And the area of g of x from negative 2 to 5 is 5. So now if we add those two together, that's going to give us 19. So this 2 is really the height. It's a box height that we're adding into that. Now for this next one, very similar, except we are moving down 6. So now we got a 6 tall, negative 6 tall, and then 7 long. So that's minus 42 for that box. But we're going to start out with this f of x, which was 18. So now we have 18 minus 42. What would that be? Let's see, we got, that's the same thing as 4 in there, and is that 3 or 24? 24. So it's going to be negative 24. Quite a bit. Okay, now for this one, this is very interesting here because it doesn't seem like you could do it, but you can. Notice how this says x minus 2. Well, I'm going to do a little substitution here. It doesn't make a whole lot of sense because we haven't practiced it that way. But let's say that I let u equal x minus 2. Right here, this is x equals 0 and x equals 7. But if I put, that means that u plus 2 equals x. Or actually, no, it's just u equals x minus 2. That's all I need. So I could rewrite this. This is the same as the integral from negative 2 to 5 of h of whatever, d whatever. Now I could put x's in there, u, it doesn't really matter. I'll put a u. But that's irrelevant as far as the relationship of h and these intervals, this interval, negative 2 to 5. So because this was shifted the same as this, then it maintains the same value as the original h of x here. That's very weird, very, very interesting and weird, but it does work. So the answer is still negative 11. Guess what? 28 does the same thing. So we're still looking at g. Notice that this is plus 2, so if we took that plus 2 and kind of shifted it to these ones, that's really going to be 5, and that's going to be negative 2. All right. Let's see what we can get for this next one. So we have from negative 2 to 5 of g of x, this is equal to 5. The last couple here, and this is a pretty big deal, we're looking at 5 to 8 of f of x. Well, we don't know what the integral from 5 to 8 is, but we do know that the integral from negative 2 to 5 plus the integral from 5 to 8, we're talking f here, is going to equal the total integral from negative 2 to 8. Well, this last piece is going to equal 0. And the first piece is equal to, was that 18? Yes, it was 18. So 18 plus something equals 0. What would that piece be? Well, it would have to be negative 18. That's the only way that we can make that go all the way to 0, by subtracting 18. Now for this last one, it's very similar. We got this shift left, which shifts this from, let's see, that's going to shift it left 3. So I got to subtract 3 here. This is going to go from negative 2 to 5 of f of x. But we're still going to have this plus 3, which means we're going to have a box that's 3 tall and 7 wide, because I went from 1 to 8, or from negative 2 to 5, but it's 7 wide. So we're going to add that much area to it. And that box would be 21. And the integral of f of x, the area under f of x, is going to be, how much was that? That's 18. So 18 plus 21 should give us 39. Alright, we're going to finish it there. I know there's going to be questions on this section. We will go over whatever you guys need to, and then you guys can practice the homework as well. But we're going to take our time, especially with this really getting into the deep calculations with area and how it can be geometric shapes, but still there's simple geometric shapes can still have a lot of complexity.